Every time I start a new video, my camera's in the wrong place and I gotta adjust everything. Okay, equivalent fractions. Am I even framed? No, I'm not. I can't control it. Trick 2, I paused it and I didn't even adjust anything. Okay, equivalent fractions. What are equivalent fractions? Well, let's give you some examples. Before we answer what an equivalent fraction is, first we got to know what a fraction is. So fractions are usually written something like something over something else, and we call this the fraction, and there's a few ways we can interpret this. It equals part over whole. It could equal, and the names for these tops and bottoms are the numerator and denominator. There's a few other interpretations you could use, but let's focus on the part to whole right now. So let's imagine down here we have pizzas or pies or pizza pies. Now if we have a whole pizza, we just call that one. We have one whole pizza. But pizza, normally you don't just eat one pizza all by yourself, although you could, and I don't know if I have. I feel like I have. But sometimes you divide it up. Here we have a pizza. We cut it into 4 parts, and yeah, 4 parts. And now let's say I come along and I want a piece of that pizza. I eat that corner of it. Yum, 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 yum. The question is, how much of the pizza, of the original pizza, did I eat? Now you could say 1 slice, but remember, not all pizzas are made the same. Sometimes pizzas are cut into 6 parts, 8 parts, 10 parts sometimes. So just saying 1 slice by itself doesn't mean much. So we want to know what that slice was compared to the whole pizza, and that's where fractions come into play. So the first question we ask, how many equal parts was the pizza cut into? 1, 2, 3, 4. And how many of those 4 parts did I have? 1. That's the example I gave up here. 1 is the part of the whole, which is 4. We had 4 total, and the one we're referring to is just 1 slice. Okay, that's a fraction. You probably know this by now, just reiterate. But let's think of a pizza that's not cut into 4 parts. Here we have a more traditional pizza cut into more parts. How many parts? 8. 8 parts. Now let's say I come along and I eat this part and that part. So how many slices did I eat this time? I ate 2 slices. But if you look, what actually happened is I ate the top right corner in this pizza, and I ate the top right corner in that pizza. But in this one, I only ate 1 slice. In this pizza, I ate 2 slices. So what's going on here? So let's rewrite our fraction for the first one. I had 1 part out of 4 parts out of the whole. And let's take a look at this second pizza over here. I had 2 slices out of how many total slices? 8. So here we have a situation where 1 piece out of 4 is equal to 2 pieces out of 8. So we can see that because we wrote it down. They each equal a quarter of the pizza. Now these are called equivalent fractions. This is what equivalent fractions are. They're fractions that are written differently but have the same value. They are equivalent in value. So even though they look different, they're equivalent in value. Now, how do we know which fractions are equivalent and which are not? I will show you how to find them and how to reduce them. Those aren't proper terms, but I'll let you know what I mean in a second. So when we have a fraction, sometimes what we want to do is reduce it. And reducing, maybe you know, maybe you don't, but it involves canceling out factors. So luckily I made videos about factors already. So what we want to do is we want to take a look at 2 and 8, and we want to ask the question, which factors do they have in common? So we can just break it down. 2, if you were to fill out your factor tree, you would get the following results. 2 is equal to 2 because it's prime. 8 is equal to 2 times 2 times 2, okay? So they both have a 2 in common. Let me just go ahead and show you the other way, or show you over here. So if we have common factors, forget about this for a second. If we have common factors, what we do is we want to divide each of our top and our bottom by the thing they have in common. So in this case, they both have 2. So what's 2 divided by 2? 1. So we can cancel it out, give it a 1. What's 8 divided by 2? Cancel it out, give it a 4. we equal 1 over 4, which is exactly what we had the first time when we just ate a quarter of the pizza. So by reducing the fraction, we have a process to see what our simplest way of writing that fraction is. Okay, so this is helpful because it shows that they're equivalent, shows they're equivalent fractions. So that's true of something like maybe we had 4 over 16. The pizza was cut into 16 slices and we ate 4 of the slices. Well, let's see if that can reduce it all. Do they have anything in common? Yep, 4 and 16 are both divisible by 4. 4 divided by 4 is 1. 16 divided by 4 is 4. That gives us 1/4. So any pizza situation where we cut up the pizza and we eat a quarter of the pizza, whether it's 2/8 or 4/16, it's always going to be able to reduce to 1 over 4 because they're all equivalent fractions. 1/4 equals 2/8 equals 4/16 equivalent fractions. Now let's say we were just starting off with, let's say we just started off with 1/4 and we wanted to ask the question, what are some equivalent fractions to 1/4? So if we're starting from a fraction trying to find others, what we have to do is we just got to multiply by something we multiply by another fraction so long as the numerator and denominator are the same thing. So let's take, for example, 2 over 2. So if we multiply 1 over 4 by 2 over 2, remember for multiplication of fractions, we just go across. 1 times 2 is 2. 4 times 2 is 8. Look at that. We found our 2 over 8, which we already know we've been working with. So if we have a fraction, we can find another equivalent fraction as long as we multiply by the numerator and denominator being the same thing. So let's take another example. Let's take 1 over 4. Let's multiply it by 4 over 4. That gives us 4 over 16. Look at that. So we know these are equivalent. And like we already know, the way we got to 2 over 8 to 1 over 4 is we divided by 2. So we're just doing the opposite. We divided when we wanted to go from 2 over 8 to 1 over 4. We multiply when we want to go from 1 over 4 to 2 over 8. The same with this fraction at the bottom. So we also use this a lot whenever we are adding and subtracting fractions. What's the rule for adding and subtracting fractions? They need to have the same denominator. So if we have the fraction, if we have 1/4 plus 3 over 16, we need to have the same denominator before we can add these things. Look back on our least common denominator / least common multiple video, and you'll see how we find it for 4 and 16. But the least common multiple for 4 and 16 is 16. So we need both denominators to equal 16. This one's already equal to 16. So we need to just change 1 over 4 to have a denominator of 16. How do we do that? So we are starting with 1 over 4. We need to multiply by something so that we get an equivalent fraction so that the end result ends with 16. Well, what times 4 gives us 16? 4. And what's our rule for multiplying to get equivalent fractions? The denominator needs to equal the numerator. So we know that this has to be 4 as well. So multiply across, 1 times 4 is 4. We found what we need to add by. So instead of doing 1 over 4 plus 3 over 16, we do 4 over 16 plus 3 over 16, and now we can add those together. Now remember, when we multiply, all we're doing is changing the numbers we see. Remember, behind it all, we're still representing the same value. Look back at our pizza. Doesn't matter if it's 1/4 or 2/8 or 4/16, we're still representing this part of a pizza, the quarter part of a pizza. That's what makes it equivalent. So the question is, how are we able to multiply by something and get something that's equal to it? So this is the cool part, I think. You don't have to agree. But the reason we're able to multiply and get the same thing, what number has the property of multiplying by something and getting the same thing? 1. The only number where you can multiply by 1 and get itself still. So if you look, what we're multiplying by 2 over 2, 4 over 4, 4 over 4 again. What's special about 2 over 2? Remember, fractions can be division problems. What's 2 divided by 2? 1. What's 4 divided by 4? 1. So really, we're multiplying by ones in disguise, and that's how we're able to get an equivalent value, even though they look different. So yeah, that's the trick. So here's what you need to remember to find equivalent fractions. Start with a fraction, multiply by the same thing over itself, and you'll get an equivalent fraction guaranteed. If you have to get to a certain destination, start with where you are, right where you're going, and figure out what you need to multiply in order to get your result. And then lastly, if you have a fraction and you need to reduce it, just find what your numerator and denominator have in common and divide by that, and you'll get your base fraction. But that's just review if you knew that already. But yeah, this is going to come into play for adding and subtracting fractions, as well as unit conversions, which is the video I'm making next. So I'll see you in that one. Bye!